Today I will be talking about Spring Boot framework, Spring Framework and Spring Boot features, and then I will switch to Cloud Foundry to show you, to share with you how you could run your Spring Boot applications on the cloud environment, being Cloud Foundry. And I will add a few features, important features to the application. But we have a very limited time actually. 45 minutes is not bad enough to share everything, many things. I will share with you Istanbul Spring Meetup link. That's a meetup group which was recently added by me, and now we have around 600 members. And we do every month, almost every month, we do meetups where we share more detailed information about Spring Boot, Spring Framework, and Cloud Foundry, other things, DevOps stuff. If you're interested, please join there, and then you can follow us there as well. Just a few words on myself. I used to actually do scuba diving and take photographs, pictures underwater. I should do it again, I think. I tried to learn playing music, this Turkish instrument. And I also like seeing things grow and turn to fruits. I have trees in my hometown. In my personal life, I'm generally interested in these things. Professional me, I work at Turkcell Technology as a software architect for about 10 years now. But besides that, this is the project that was most interesting for me, most enjoying for me. This is an excavator designed and built by Turkish engineers in Izmir, and my brother is leading that project, and I helped them implement the software running on this machine. We have 2 of these machines now, and I hope the project will grow and new ones will be introduced. Okay, coming back from the industrial software engineering to enterprise software engineering. This is the picture, the last slide I want to show, because it's important for why I am talking about today Spring Framework, Spring Boot, Cloud Foundry, Cloud Native architectures, is basically summarized in this picture. Considering a typical enterprise application or a brand new startup application project, more or less you will end up with something like this. You will have devices, your clients, users, connecting to your applications to get service. But behind the scenes on your cloud execution environment, you will make sure that your application can store data effectively and properly. And the most important one in this picture, I believe, is the security. You must store your information securely. You must open your services, API services, to your clients securely. And scaling is another big concern, because imagine one day you will have many more users than you expected, so you should be able to react very fast and then scale up or scale down if the load is going down. Analytics, you should analyze your data in order to improve your business. You should implement your business logic. That's the main concern, but I generally mention this last. The framework that you use should help you as a developer or the team of developers, help you implement your business logic effectively. It shouldn't take ages, months to implement or to change the feature behavior of your application. And of course, integration to backend systems and cloud services is another key issue. Okay, this is the last slide. I have others, but I don't have much time. So I will switch to code, and I will do hands-on demonstration of Spring Boot application and how to run it on Cloud Foundry. If you have any questions, please do interrupt me. I'm skipping these parts of the presentation. Okay, I have the project on GitHub. I have recently cloned it to my local. This is my repository. You can, in the future, you can go and clone yourself. This is the Spring Meetup. The recent meetups, you can go into details or follow us with the upcoming meetups. Now here's the code. As I said, this is a Spring Boot application. Before going into details, who is using Spring Framework, Spring Boot for doing their daily? Very good, almost half of the group is Spring Boot. Who is doing DevOps? 1, 2, 3. And hopefully it will increase after this session, I hope. Okay, we don't also do DevOps. We are thinking about doing it, but it's not easy, I know. Conceptually, I will share how you do it. Spring Boot is based on Spring Framework to make things easy working with Spring Framework. It's not very easy. It wasn't very easy to implement a project in Spring Framework. You had to define all the dependencies in your POM XML, and you had to define all the beans, etc. Spring Boot is just making it easy to work with Spring Framework. Short. Okay. I will import the project. This is a Spring Boot application. And then I will show you what we will gain at the end of this session. I will run this plain old main class. It's nothing special. It's just a Java class with a main method, including one line of Java code and a few Java annotations. This will get me a running application server where my application is deployed, including all the REST controllers, REST APIs, and web pages. Let's quickly have a look. We don't need this anymore. It's running on localhost 8080. Okay, this is the application we want to achieve, we want to see. It's a very simple application. What it does, it will query the current weather information from Open Weather Service on the internet, and then show the results on a web page. Or what it will do, it will provide us an API service for querying current weather of a specific city that we want or our users want currently or weekly. If I query for weekly, it will show me the weekly weather forecast for that city. What we will do, we will add a few features on it because we have very limited time. We will not be able to go through many features, but caching is an example I would like to share. I would like to show you. Before going into details, let me do a very simple application for those who do not already know what a Spring Boot application is, how it is composed. Just one REST controller I will add. What I do, I create a Maven project, quick start, or demo is my group ID, test is my artifact ID. Okay, it's an empty project with nothing, just saying hello to the world. We will take this hello world and convert it to a Spring Boot application. In order to be able to do that, we need a couple of things. I will not type them, I will just cheat them because it takes time. Oops, so not this one. Okay. To be able to make a project Spring Boot enabled, all you have to do is, not here, I will change it from here, it's better. Okay, all we have to do is provide a parent artifact to our Maven project. Okay, tweak these properties, make it Java 1.5, and make its parent Spring Boot starter parent. This is the first thing. If I do this, my dependency hierarchy did not change, but after the second one, it will change a lot. I will introduce one more dependency, actually the first dependency, in the POM, formatted. Now, if I look at the dependency hierarchy, you can see that it will bring a lot of things, a lot of dependencies, a lot of jar files to make our application Spring Boot enabled. Before, it was really difficult. It was really hard to keep all these dependencies and their versions. Now I don't bother. I just want that my application will be a Spring Boot starter web application. Before running Spring Boot application, I need to do this Spring Boot application annotation, and then change the hello world. We want something more than hello world. We want this Spring application to run with this configuration provided in this class. Okay, one annotation, one line of code. This is still a Java main class, so I can run it as a Java application or Spring Boot application because this is STS, Spring Tool Suite. Oops, probably the other one is running. Hopefully, yeah, it was running. Okay, I start again because 8080 port was occupied. Okay, now our application is running. One Tomcat instance has been started. Our application has been deployed, configured, dispatcher servlet, other things. But it still doesn't provide much. If I go to localhost 8080, I will probably have 404 because there is nothing serving there yet. Let's try to reach this test. REST service doesn't return anything. So what we will do, we will add quickly one REST API controller. REST API controller. To make things special beans, special classes for Spring Framework, all we need is this annotations, REST controller, service, component, configuration, bean, this kind of stuff, and a request mapping that will serve our requests on this URL /test. And it will just return hello from this method, return hello from REST to the world. Okay, I will rerun. Now I should see something added here. A new mapping to a REST service. I will call it, and I will get the response. Okay? Believe me, the ones who already do Spring Boot know what I mean. All the projects from very small scale to very large scale are implemented based on these very basic things, principles. An application that is built in Turkcell technology by me and the team I'm working with is similar to this one. Just these lines, of course, but more business logic added, more functionality added on top of it. Any questions so far? Good. Okay, so I go back to that application, weather application, and then I will show some more features on that. Let's quickly go through the weather application. The same principles, the same structure. Let's quickly have a look. Weather app. It is also a Maven application. It should specify the Spring Boot starter parent, as we do. It will include starter web, so this will be a web application requiring a Tomcat or JK, whatever it is. Spring Boot starter actuator. Mustache is a web template like TimeLeaf or other templating engine. Thank you very much. Spring Boot Dev Tools is a special artifact that helps us run our applications on our local without restarting. If I change one line of code or properties files, it will automatically redeploy the application. JS I think is not important. Test and REST docs. I would like to show this part as well very soon. Test-driven development is important. I personally started doing it 2 months ago in my own work, and I really liked it. I strongly suggest you also to have a look at it, because I did not know, I did not understand what it used to mean. Now I have a better understanding, and I really get benefit out of it. Test-driven development and pair programming practices are good things, and Spring Boot also supports these things. REST docs will generate our API documentation automatically. Let's have a look at that first. Okay, we are here. We will do name and package. As I said, test-driven development is a good thing. So what you do your test-driven development and you implement your tests. Here you have your API controller test, mocking beans, expectations, assertions, all this stuff. I don't have time to go into detail, but there is a special test case here. This test suite, actually, what it will do, it will run as a plain old unit test, but at the end of unit test, it will do documentation. It will document the API services, REST services. Normally, what we do, let's be honest to ourselves. What we do start writing code, we add business logic, we come up with a solution, we deploy it, then a specific client needs to be integrated to our services. They ask where the documentation is, then we start writing documentation. Is that correct? No? Okay. I trust you. But this takes time, and it is generally, it becomes out of sync. We keep implementing, but the documentation remains behind. If you do this approach, your documentation will be automatically generated at each compilation, at each packaging of your continuous integration. I will show you the result immediately. It is going to be something like this. Okay, there's a table of contents. We have two APIs, current weather. You can see that the input parameters, its documentation, an example URL, the response field definitions, a typical response. This saves time. Okay, that was the first feature I wanted to share. Another feature I want to share is caching, because what happens currently in this application, let's run it again. If you have questions regarding these things, please come to me afterwards and we can discuss. I can provide more information. Okay, I started again the application. Every time I click on the service, what is this? Let's have a look. Unknown host, of course. Because we need to go to the. Okay, let's try again. Okay, now we have the service. Let's look at the log. It will request the weather information for those cities. I request it again. It will ask again because there is no caching currently. How you do cache support in your Spring Boot application is like this. You will need to provide few more artifacts, and I will cheat from here again. XML, this one. Okay. Spring Boot provides us cache support, and then it will provide us Redis support. Also, I have to declare where the Redis is. I will use Redis on my local in the application properties. Okay, localhost. One more thing, I will have to enable caching. Normal Spring Boot features are generally disabled. You need to enable them to make them active. Okay, import is also fine. Let's rerun our application. Before going into detail, I will show you the Redis instance on my local. It is empty, there is nothing, no entry. I will start the application again. since the cache is empty, I will see the first 3 requests going out to the internet, and then the second ones served from the cache, local cache. Okay. You see, it's requested, clear. Let's make sure that we don't see the last 3 lines of requests. Now return from cache, and let's make sure that Redis as our entries. Yes, we have 3 entries there, mapped by Spring Boot cache features. Okay, so normally we would spend quite a lot of time to configure Redis connection, JDIS, its other Spring Beans in order to make our Spring application cache enabled. But with this, what we do, to summarize, is enable caching and then introduce 2 artifacts, dependencies, one for Redis, one for Spring Boot Starter cache, and then define where Redis actually is. That's all. Any questions so far? I'm probably going fast, sorry, but as I said, I have quite a little bit of time. Now, we move forward to Cloud Foundry. This is an application running on my local. Traditionally, generally, we deploy our applications to operations, to infrastructures where operation teams are in charge. They have full control, developers cannot access, they don't even see the logs, and generally our applications are executed on Tomcat, JT, WebLogic, JBoss, application servers, containers, as WAR files or ER files. But this approach is changing with DevOps, because DevOps means remove the walls between development teams and operations teams, because otherwise what developers generally do, anybody from operation teams here? Operations teams? Everybody developers? I think so. What developers do, they just package the code and then throw it behind the wall because they don't see what is happening. It's not their responsibility. So the hot potato ends in the hands of operations teams, and they are the ones waking up in the middle of the night and taking responsibility for what is going on. And then they push back to developer if they find a bug and they become happy because it's now developer's responsibility to think about it, not to sleep and solve the problem. But DevOps aims is remove the wall. Developer is also in charge, responsible. Operations is also in charge. Looking at, of course, from different perspectives, but sharing the responsibility. In order to share the responsibility, these cloud-native architectures are introduced. Docker or there are other solutions. Microsoft Azure, I think. These platform as a service solutions. Cloud Foundry is just one of them. Nothing special. But I will show you how to execute this Spring Boot application without changing anything, without making any extra configuration. That's the part I'm most interested. I would like to highlight most. Because as a developer, if I start having new roles, new responsibilities, new things to do, I'm generally running out of time for doing business implementation, for doing development. If I have to deal with extra stuff, I wouldn't like doing DevOps, right? So I will execute this application on cloud without changing any code, any artifacts, any properties, any nothing. Okay. What Cloud Foundry is? It is a open source project. It has got its own foundation, Cloud Foundry Foundation, supported by quite many big companies like Pivotal, SAP. They started shifting their infrastructure to Cloud Foundry, and then there are other companies. It's an open source project. You can download a developer version I recently tried that. I downloaded PCF-Dev on my local, this laptop. I reserved half of the memory and then it runs on my local. I can work with it. But this is the cloud version, deployed on Pivotal services. You have got an organization or few organizations, and you have spaces. Within spaces, you have applications and services. The keyword microservices is can be interpreted in different ways, but I will show you the aspect of microservices being like my application getting service from, say, Redis as a service. I'm not going to break this monolithic application into different microservices. That's another aspect. What I will do, I will make use of existing services bound to my application, which is Redis, basically, in this scenario. Okay. In order to do that, in order to be able to deploy an application to Cloud Foundry, you have a command line interface. Where am I? Okay, web. In the command line interface, you will need to log in to Cloud Foundry instance. There is a command line interface, CF login. You specify where the Cloud Foundry API is located, and you specify the username and then provide the password. This is the username and password that I used for logging in here. It's the same thing. Okay, it picked my organization, MySpace. Now every request that I will do with CF, like pushing an application, stopping it, starting it, listing it, will interact with that service. One more thing, in order to run an application on Cloud Foundry, we will need this manifest file. It's a very simple file. Let's find it, manifest, and then put it in our application. What it will do, it will just specify what the name of my application is, how much resources I would like to reserve for this application, routing rules, and then the services. Let's first try to see if it's gonna work without binding the service, Redis service to the application. What I will do, CF push. It will pick the manifest file. It will pick that the executable is this jar file, which is Spring Boot enabled single executable jar file. It's not a library jar file. It has many stuff. It's probably 10 or 12 megabytes in size currently. It will upload my application to Cloud Foundry and then do some magic behind. I'm not going to go into details. Stop the existing application, start the new version because it's a new version. It will download some build packs. It will basically look at the nature of your executable. If it's a .NET application, it will find a .NET framework, install it, wrap your executable within the framework. If it's a Spring Boot application, it will do Java runtime environment 1.8 and then Spring auto configuration stuff. And we will see if it's actually not bound, I think. Let's see if it's okay now running. It is starting the instance. Yes, the instance is starting now. As I said, it will do routing automatically, so there is no more firewall requests, there is no more routing, DNS stuff, load balancing stuff. It will automatically be done by Cloud Foundry for you. If, as I said in the beginning of the cloud picture, remember that picture, scaling is important. If the load increases suddenly, that's a good thing actually for your application, for your service product. It's a good thing. If it increases suddenly, Cloud Foundry will automatically scale up your application. It will introduce new instances. Currently, I'm running on one instance with 1 GB memory because this is a demo version, so I have 2 GB limitation. But your application will be executed by Cloud Foundry without changing anything. As you see, I did not do anything, just edit manifest file. I did not change any source code. I did not change any configuration properties. I did not introduce any Maven dependency artifact. All I did was pushing the executable jar file to Cloud Foundry, and Cloud Foundry will take care of the rest. Let's try to scale up. I have not tried this one, but we will see. As I have 2 GB limitation, this should be okay. 2 instances, scaling up to 2 instances. You see the first one is up, the second one is starting. Let's see what happens. If I want to see the logs of my application, I can use CF command line interface to connect to Cloud Foundry and get the logs on my local, because monitoring is important. It should start tailing here. Okay, we have 2 instances. The first instance is consuming this much of memory and this much of CPU power. Why don't I have CS logs? Because there is not much going now. I should make a call. You see? Now we will see the instances printing logs. Okay. Any questions? Interesting?
Can we use Cloud Foundry in our APN network and in-house apps?
Data center and in your own network, right? Yes, you can. Cloud Foundry, as I said, it's an open source project. You can download the open source version and run it on your infrastructure. All it will require is an infrastructure as a service, infrastructure, IaaS. Because Cloud Foundry is PaaS, sitting on top of the IaaS infrastructure. You will specify the amount of CPU power. You will provide the amount of memory power and disk capacity. You will provide as a resource, as a pool, and then Cloud Foundry will manage that resource for you. You will not bother waiting for months. We wait for sometimes 6 months for one server to get shipped and accepted by local guys and then installed in our data center, operating system installed on it. It takes many months. But here you just provide the resource. Cloud Foundry will allocate required amount of resource for your application. If your application needs to be scaled, it will just pick another virtual machine or physical machine, and it uses that machine's resources for your application. So you can do it. We are trying to make a POC in our own data center. I can share if we succeed with you if you're interested. Okay, this is how the application is installed and executed on Cloud Foundry. Let's have a look at how the services are bound, because we talk about microservices. Here, as I said, the scenario is Redis is a microservice for me. Database is a microservice for me, for my application, not personally, but for my application, of course. Or application performance monitoring, APM. We spent a lot of investment on doing Dynatrace or other solutions. Here, New Relic is a service. RabbitMQ, messaging queue, MySQL, PostgreSQL, Oracle, many things. There are many things you can imagine generally you need to use. They are all defined as services and bound to your application according to your needs. Let's go into that detail. As I said, I have a Redis instance here. I can have other services. There are, I think, 50 or 60, something like that, services. For example, PostgreSQL, MySQL, Memcache solution, Redis, Elasticsearch, what other things? There are other things. All you have to do is, for example, let's make a MySQL. There are different plans. This is the free one, but it's limited up to 5 megabytes. If you pay money, you get more space, more feature. I just select this plan. I call it MySQL service. I'm not going to use, I'll just show you how to do it. At this time, you can already specify which applications to bind, or you can just leave it empty and then bind it later. From your manifest file, how you bind an application to your, how you bind a service to your application is like this. You just say it here in the manifest file. You specify which service your application needs to use. Once we do, we can re-push, CF push, will not be lazy. It will, next time, I will not need to do the binding on the console. It will automatically be bound to Redis service. Okay, it is restarting. Probably it will fall back to 1 instance because I did not specify the number of instances in my manifest file. Let's see. I don't know. We will see together. We can call it here as well, or here in the logs. You see, I can fetch the logs from many places. Okay, starting. Instances are still two, there are still 2 instances. I will show you in the meantime, while it's running up, the management of these services. These services, I think there is an agreement, there is a contract between a Cloud Foundry service and Cloud Foundry platform. So Redis, for example, needs to implement a contract in order to get integrated to the Cloud Foundry platform. Based on your question, if you do it on your local data center, local infrastructure, you can still bind these services based on those contracts. It already supports all these services. You have your Redis on your local data center, you have your own database, MySQL, Postgre, you have your Elasticsearch. Cloud Foundry will bring them all together. It can also manage the scaling factor of those services as well. If there is a lot of load on Redis, it will increase the number of instances of Redis service as well. It will manage those services as well. What I do, I click on Manage, I go to Cloud Hosted Redis Service console of my application, because I own this service. I create. Do we have a problem on network? No, okay. Here you can see that I'm connected to, it's a single sign-on. I don't need another username and password. Pivotal Cloud Foundry username and password is enough to log in here. I will go to dashboard. I will look at the day. I will just show you the activity. In the morning, I did a test. And in that test, the weather data for those 3 cities were cached in this Redis. Okay.